Hi, in this video, we're going to talk about what are forces. So, simple definition, a force is a push or a pull. And a force is the result of an interaction between two objects, one object interacting with another. Force is a vector quantity, which means it's fully described by magnitude and direction. And force is measured in newtons. 1 newton is the amount of force that you need to accelerate a 1 kilogram mass object at 1 meter per second per second. And so the unit of 1 newton is equal to 1 kilogram times meter per second squared. So forces are really important in physics. They're everywhere, and that's why it's important to begin by categorizing the forces, making sense of our world by trying to put things into categories or groups. There's 2 broad categories for forces. There's contact forces and then non-contact forces, or in other words, action at a distance forces. So some involved an interaction where 2 objects are in contact or appear to be in contact with each other. And then the other kinds of forces, they are not in contact with each other. So some contact forces, you've probably heard of these before. We have friction, tension, normal, we'll talk about that one, applied, spring, and air resistance. Those are all examples of contact forces. There, of course, are more, but these are just some simple categories. And then we have, for action at a distance, gravity, electric, and magnetic. Oh, how did that get on there? Okay. All right. So let's look at our first example. We've talked about this one in previous videos, but gravitational force is a pretty essential one to talk about because every object on Earth experiences the force due to gravity, and it's proportional to the mass of that object. So the symbol we use for gravitational force is Fg. This is also the same as the weight of an object. It's the same thing. So the force due to gravity is equal to the mass of the object multiplied by this g value, and g represents the acceleration due to gravity. And so on Earth, that's negative 9.81 meters per second squared. You'll notice there's a negative sign in here. We write it as negative because the gravitational force is directed towards the center of the Earth, and in many cases that just means down in normal situations. And so because gravity is directed downwards, it is almost always signified by a negative direction. And then finally, one other force I'll talk about in this video is the one that often counteracts the effects of gravity. So instead of all of us spiraling in towards the center of the Earth, we have another force that supports us and keeps us from falling. And that's called the normal force. Symbol for normal force is Fn or F norm. The normal force is that support force that's exerted on an object that's in contact with another stable object. So, for example, a physics book on a table is being pulled down by the force of gravity, but it doesn't fall to the ground. It doesn't accelerate towards the center of the Earth because the table exerts an upward normal force on the book. And so the 2 forces are balanced. The normal force is equal to the gravitational force, just in the opposite direction. It's up, whereas gravity is down. So these 2 forces are equal to each other in most situations, and that's why we typically say they balance each other out and they support, the normal force supports an object against the pull of gravity. Why we call it normal force is because normal means perpendicular in the math world. And so the normal force direction is always perpendicular to the supportive surface. So perpendicular means it's at a 90-degree angle, right? So in the table example, the normal force is at a 90-degree angle to the table's surface. The normal force can also be present in horizontal directions or at an angle. So for example, if you lean a ladder up against the wall, that ladder is supported by the wall. So the wall pushes against the ladder in a direction that's perpendicular to the wall. So the wall is up and down. The normal force is horizontal in that case. So that's all I've got for you in this video. Remember, happiness is not having what you want. It's wanting what you have.